Okay. So, good evening, everyone. Welcome to this event, Present Your Thesis Dissertation from CIPA Emerging Professionals. We are very happy to have you all here with us. And today we're going to listen to the presentation of Hend Alasmar, and she graduated in Historical Building Rehabilitation from Bologna University. She's an architect and she's an expert in BIM modeling for historical architectures. And today she will share with us her master's thesis. She graduated last year, and she carried out a project in geomatics engineering for cultural heritage at Bologna University. Her thesis title is HBIM to Virtual Reality Workflow for the Management of Industrial Archaeology Immovable Assets. And we also have today with us three experts, Professor Minna, Julia Laninga, and Fulvio Rinaudo, which we thank very warmly for being here. So thank you very much. And now, Hend, the floor is yours, and later we will have the discussion with our experts.
Thank you, Anna. I assume you can hear me well.
Yes.
Okay. Good evening, everyone, and thank you for having me with the CIPA this evening to showcase our thesis work with the Department of DCAM at the University of Bologna. Today I'll be presenting a research project that it was basically all about introducing a workflow, a complete workflow from HBIM to virtual reality, with the case study of one of the landmarks of the industrial archaeology in the city of Bologna, which is the 𝘋𝘬𝘍𝘀 complex. Throughout my presentation, the objective should be visible to the audience that it's all about storytelling for this location, for this landmark, and also for the valorization of industrial heritage that is not yet well celebrated or well researched or researched enough, especially for the hydraulic structures, historic structures in Bologna, and also for the preservation of the industrial memory of the city. This is the outline for both the work that we've done throughout the course of nearly 8 months. And I'm here talking about just my part all over the lifetime of the project, because it started way before my collaboration and it's still undergoing development by the team of the geomatics. In the period where I collaborated, for my thesis, it began with the literature review, because it was important to trace the development of definitions for both building information modeling and virtual reality, and it was over the time span of the last 50 years up until the writing of the thesis. Then it led to an overview of the current state of art in both fields for BIM and VR. Then the research question developed from the definition to and extended to the obsolescence of a building. How can we judge or can we mark the 𝘋𝘬𝘍𝘀 complex as obsolete or no? And also the challenges that faces the morphology of industrial archaeology nowadays. And for this, we sought help. We reached out actually to the Museum of Industrial Archaeology and Industrial Heritage of Bologna, which is very close to the site of our case study. Then also, what are the possibilities that HBIM can offer beside the visualization in virtual reality environment for different users. So myself being a structural engineer, I would expect and appreciate the model in a different way than maybe a restorer, an architect, or even the public general, or the general public, I'm sorry. So that was also investigated in the thesis work. And also, it's important to mention here that during the literature review, it became evident that the discipline of industrial archaeology did not become a scholar discipline in Italy as like in parallel with what happened in Britain and the rest of Europe. There was still a cultural debate and we would say intolerance towards the whole industrialization values. And therefore, the industrial archaeology could not form a national identity, just like in Britain. And that was, to us, an interesting point. That indicated, yeah, that's why industrial archaeology is not taken care of enough like other archaeological sites in Italy. For the workflow that was proposed and actually executed for the course of those 8 months, here we can see from the left to the right, this is how it developed. So starting from acquiring the building knowledge, and that was acquired according to the guidelines of the Italian Ministry of Culture concerning cultural heritage. There is a published document about the valorization of the existing buildings and how to for the analysis of seismic risk for these buildings, called the knowledge path. And this knowledge path is very well proposed and defined in this document, and we actually followed this path as much as we could. And it's shown here in dotted lines because it means that it was a continuous step throughout the entire process. So for the building knowledge here, you would see in my screen, we started by defined steps. And those steps, we don't say that this is the whole entire proposed path by the guidelines, but that was sufficient for the meantime for our type of work. So we started by the identification of the building location and its urban context, then a geometric survey, and this we will elaborate more because that was the biggest part of the work actually. A historical analysis of the building transformation from the hypothetical original configuration that we could read and see in the museum, and throughout its current state, the existing building that we can see. And the fourth step was the identification of the elements of the resisting organism, or the framing structure, the structural framing. And lastly, the identification of materials. And that was by visual inspection, mostly done by visual inspection and documented through the reality capture following step. For it's important to talk about the water history of Bologna before we go further with the workflow. So here, it started during actually the 12th century due to the growing demand of water. The Savina and Reno rivers, they were used to be the main source of water. Now, if we rotate the map, this is the north, and we can, I don't know if you can see my mouse, but we can see the the two rivers here, the Savina and Reno, and on the right, both established the San Rufilo sul Savina and Casalecchio sul Reno locks. So for facilitating the navigation through these two rivers that provided, mainly they were the main source of water for the city of Bologna and the surrounding. There were two types of locks, like the hydraulic structure that we will talk about later, constructed on these two rivers. And then a huge investment actually was dedicated to improve the whole hydraulic system and stretching with the objective of stretching Bologna's water basin by creating two other canals branching off the Reno and Savina, then adding a route that is called the Navile Canal. It was used mainly for the transportation and like for commerce, navigation, and even for transportation of individuals until 1948. So in the map here, this is a more recent map for the same waterways of Bologna that I'm talking about, and the Navile you can see here to the north. This is the Navile Canal. Not just water, but also that hydraulic system provided electric power to both brick and silk industry that were well established in the surrounding of today's Battiferro. And now, today, if we look at the Google Maps, actually this, like the one in red is the Battiferro, our case study. And along this line, before and after the Battiferro, you can see these pinned locations for what used to be those navigation canals, the hydraulic locks. Actually, in one of the historic documents that we found, that was a profile section taken on the same line that we saw earlier in the map, with all the navigation locks throughout the Navile Canal, and our case study, in case you're seeing my cursor, this is the Battiferro that we're talking about. For the Navile Canal that branched later into two other canals, we can see here the Fossetta. This is the first canal, and then they added also the Canalazzo. The function of the spillway, or the reason why they spilled it into two spillway, is just for the excess water management. The system of the Fossetta, that is called today Il Sostegno del Battiferro, or the Battiferro lock, and the detention basin of the Canalazzo acts as a system for regulating the flow of water at the downstream. According to the documents that we found, the first form of this building or of this construction, it was formed in 1419, and it was rebuilt later. The first form is believed to be, because we didn't find evidence on this, in wooden structure. And then by Vignola, it was transformed to what we can see today, to those two buildings. I think we will see, here it will be more clear. The two buildings that we can see in this photo, one of them is the Casa di Manovra, the maneuvering house, and the Casa di Custode, or like the storage, and also for administrative work. Both buildings were the service buildings that served this whole system that we can see for the lock. The lock, as we can see, it has a detection basin, and then three floodgates that regulate the water, and this is the whole point of having the lock, is once the water level gets higher, the gates would lock, and then to increase the level of water behind these gates, the gates will rise and let the water in. From this point in the presentation onwards, you will see below there is a bar with 3 different words, either scan, BIM, VR. Back to the title of this presentation, it's HBIM to VR. HBIM is sometimes is used also as an equivalent for the process scan to BIM. But scan is not the most precise word because there's reality capture to BIM. And that was actually the campaign that the entire team has been designing and executing even before my collaboration on the project. I took part in certain phases, but a whole campaign was designed to have a complete stereometric description of the 𝘋𝘬𝘀𝘀, and that was actually a step further on the knowledge path. And it was, or I had to face them in based on the object that was scanned or captured. So for instance, we see here exterior 1, 2, and interior and masonry. So based on the target spaces, we would see the first one, which is the exterior. Still, we are in the scanning or reality capture step. A total station here was established and collected during, before and after the survey campaign to evaluate the accuracy of the surveyed data. It enabled the determination of exact spatial locations with respect to the predefined coordinate system, while creating also a network of surveying of 4 stations. And these acted like a reciprocal collimation for the whole process onwards. So the reference was established through the total station. Then that was actually the scanning of below the building, like at the water basin that is today is dried with respect to the past, obviously. And that was still the part of the exterior, or the surveying of the exterior using a laser scan. Yeah, sorry for that. The second step was for the interior. By visual inspection of the interior, we found that the spaces were characterized by homogeneous surface. So a decision was made that it's enough to do the laser scanning at that point, and scanning or surveying of the whole interior of the building was executed using a laser scanner. And then for the exterior, another reality capture phase was done, especially for the roof system and for the topography of the area, using photogrammetry with a drone, like unmanned aerial vehicle-based photogrammetry. It was performed and controlled from the ground. In those 3 slides, we would see on the in the middle the instrument that was used, and on the right the point cloud that we obtained later by the processing of the data that was collected by the rest of the team. For the machinery, however, especially in the maneuvering chamber, the room contained the organism of the mechanical components that used to make the whole the lock basically functioning. and it used to control the 3 gates of the detention basin underneath. The machinery had to be surveyed by means of structural light projection scanning. So, and on the right, we can see an example. It's just one segment of the product that was obtained later for the machinery of this room. That was the mesh that was produced, that was used later for building information modeling. Now we ended up having, after the data processing and manipulation, we could obtain 3 point clouds, each by its own software that was used either for the scanner or for the photogrammetry, throughout the photogrammetry path, or using the laser scanner. The unification of these 3 point clouds required scaling and alignment, and they were later merged by means of Cloud Compare. Then they were imported into Revit, start the modeling phase. Now we can see the 3, like we finally had the 3 different scans. It's called scan locations. And the point cloud, the unified point cloud here were inserted in Revit as a reference. For the building information modeling stage, the second stage for this workflow, we had 3 different considerations. We wanted to describe the motivation behind certain decisions, like we made informed decisions. And those decisions were needed to be clear for whomever would access the model later, for the sake of the transparency of the process. The second consideration was to identify the level of reliability of this model, either on the geometric level by comparing the model to the point cloud. That was also a step that was done on Cloud Compare to see the margin of error that was obtained later, and on the information level by relying on reconstructive hypothesis, especially for the architectural elements. So, for instance, if we see, if looking at a wall, it's obviously a brick wall, brick masonry. This is an interesting information, especially for architects or engineers who would probably intervene on the project later. So we needed to document how we judge this wall. Was it based on visual inspection, or also based on the photogrammetric campaign that we executed? Then also the third consideration was to create a strictly open BIM model that we're sure, or we wanted to grant an interoperability with other disciplines or other BIM software, and also to be used on the long run by other applications. So IFC identities were defined in the model. The model was also obtained, but it was not just modeling by Revit. We tried also to model with other BIM software to see which one would be more efficient for the structure, might not be efficient for the machinery, and vice versa. Here I would give examples of such decisions that we had to make, or for interesting modeling aspects. For instance, here for the creation of the masonry wall pattern, the exterior walls carried information about their stratigraphy, the layers. Some information were uncertain, some other were more certain. And for this uncertainty, there were information inserted for each element in the comments for each wall, for instance, we had to insert a comment that says that this is a visual inspection. This is a hypothesis. So for future interaction with the model, the future professional would understand that this information needs more investigation. Also, the state of deterioration, if it was visible. From the picture here, we can see that we had two different patterns for masonry, the Flemish bond and the stretcher bond. Only one of them was available in, the running bond was available in Revit. And this information was also interesting to be modeled, custom made, to make the difference seen even in the Revit environment without having to go for a rendering software or a virtual reality. So from the Revit model, the user can still see the difference in the patterns. Also information about the masonry condition. Is it a good masonry or it needs intervention? So that was the pattern after development. Also, the second example is the mechanical components. These mechanical components were the ones that were scanned earlier by the structural light scanning. It was decided to be modeled maintaining minimum level of information and average level of geometry. By this, I mean that we did not model the most detailed segments of the machinery, because it was needed only for the integration into the virtual reality environment to see the mechanism, how it used to function. So therefore, it was modeled in place. The decision was made into Revit. Another software was used to execute this. As far as I remember, it was not Tekla structure. It was one that I would later put in the notes, that it was not a good choice. Like, we realized later that it was not a good choice to be included in our model, because it will not be easy to move it later in to make it animated in the virtual reality software. So the decision was made based on this issue that we had. Then, like a parametric family for the creation of a window, this also was based on visual inspection and geometric survey, like site measurements that could be obtained as far as we could go. Then, that also was, here we can see an example for the transparency that I was talking about, that the information about a load-bearing exterior wall and interior wall was determined with reference to the point clouds, of course, but because it's this kind of connection is quite sensitive and critical for structural interventions, because the node where the corner meets, it should be exactly 90 degrees. So we had two choices, either to model it as 90 degrees all over, or to follow the point cloud that showed those different angles. So the decision was to make it create it following the status quo of the building and do it according to the point cloud, and extracting a drawing for this specific part within the project documents to communicate for future professionals that, look, this is the case, the status quo. It's not all 90 degrees. For later on, the traditional 2D layouts were executed, were produced using Revit. And then back to the cloud compare point, that was the reliability check in this process, that on the geometric level, to compare the mesh of from the reality capture phase exported into Revit with the final point cloud obtained, like the final point cloud versus the model that was created, we made another check by measuring the distance between each point on the mesh with the corresponding point on the point cloud, and then another confrontation was done between the unified point cloud and the model that we created. Here in this histogram, it's basically, it's a known product from Cloud Compare that shows the distance that I was talking about. On the x-axis is the point counts, and on the y-axis it's the point counts, and the x-axis is the distance between 2 points.
But sorry, distance expressed in which unit of measurement? There are meter, millimeter, centimeter.
If I remember well, because it was like this, this material was confidential for the team. I mean, for that Cloud Compare part, but I remember it was millimeter. But I'm not sure about this. I think this I have to check again. Back to the product, the final product out of this BIM model. There were 2 videos actually produced after the transfer of information between Revit and through the virtual reality Twinmotion, the virtual reality software. We used we exported a file in the format of DataSmith. It was a DataSmith file. In these 2 slides, we will see the capacity and limitations of the virtual reality tool when it's applied to the HBIM model. The first scene, it shows the navigation. I think, yeah. So that was an imagination of the maneuvering room and how it used to, this information was added like notes to see an example of how we can, what kind of information that we can communicate to the user. The sounds were added. I don't know if it was clear in previously, but like the whole environment can be also simulated by sound, the sound of water, the sound of machinery. And the material was added also as textures. So brick was added, for instance, reinforced concrete, etc. And the interesting part is the state of deterioration could be presented. It was not a quantitative representation in the sense that we in the virtual reality, until the point of executing or writing the thesis in Twinmotions, it was not possible to show this is a crack of 1 centimeter, of a size 1 centimeter throughout a length of 1 meter. It was not possible, but it's possible to put an indication of the deterioration just to as a tag. Like here, there is a crack. It can be a diagonal crack. It can be vertical. This needs more investigation. Here, there is humidity effect on the brick of this part of the brick wall, etc. The second video, it was also a simulation of an imagined scene of how the boats or like vehicles used to navigate through the log gates. So the water level changes And this intermediate phase, this is where the water was regulated between the upstream and the downstream. The vehicle waits until the gate lock, the second lock opens, and then it carries on in its path. Sure. Okay. Oh. Okay, can you still see my screen? It's just not responding. Okay, until
we can still see your screen, yes.
Okay, so until it gets back, it's important to say also that as the equipments that we had in the laboratory of geomatics, it allowed for an interesting comparison between two different visualizers, or two different headsets for virtual reality that we actually tested to explore the same model in VR and compare the quality of the experience between them. So we had the Vive Pro 2 and Oculus. Vive Pro 2 has two differences from Oculus. First, that the headset has to be connected to the computer with a cable, exploiting its computational power. The resolution of the display was higher compared to Oculus. I hope that the presentation would unfreeze soon, so we can see the registration like we registered while experiencing these two headsets. The wired Ethernet connections are faster in general and more reliable, and it has lower, or it demonstrates lower latency than wireless connections. And this is the case for the Vive Pro. While the two headsets have different specifications listed on their websites, the Oculus is intended for non-professional use, and HTC Vive Pro is engineered for professional grade virtual reality. The quality of graphics also is compromised in Oculus with lower display resolution that was also experienced and documented here. Due to the lower refresh rate, for it's noticeable that there is a lag that we experienced during the navigation scenes for the same model, for the same position. Like we tended to start from the same point for each experience of them. For Vive Pro, the overall experience was smoother with no lag compared to Oculus. For the, I don't know if I should restart or, but okay, we're approaching the end. For future development, actually, we tested what was the compatible platform for that moment to experience the HBIM model and see within the potentials that it could offer. Obviously, there are different platforms for virtual reality visualization. So this is something to be investigated. Also, the optimization of the produced model on Revit is also needed for because in 8 months that was the work done, but it could be developed in with richer information if needed, with more detailed modeling for the interesting architectural details. Also, the the level of accuracy and level of reliability could be further studied, in the sense that it needs to be, it's now being standardized actually, like it's under still under research by Building Smart, for instance. On the other hand, while it can be also project-based, so for the 𝘋𝘋𝘪𝘠, in the future, it could be said that, okay, for the level of transparency, the information should be registered, the information used to make decisions should be registered in this field or associated with this parameter in the project. For the level of accuracy, depending on the purpose, if the project, if this model is going to be used for visualization for users in a museum to enjoy virtual reality experience, the model will be developed in a different way than if it's going to be used by engineers and architects who would need to design and execute interventions for seismic for seismic rehabilitation, for instance, for the building. For the reuse of the building, also a different level of accuracy would be needed. So there will be needed information about the connection between the machinery and the ground. So it's not enough to do just a photogrammetry or a structured light scanning for the machinery. No, we need in-depth investigation, more information about the stratigraphy or the layers of the walls, etc. So this could be also an interesting development in the future. To conclude, this is the output we had, like 3D reality capture to a BIM model to a virtual reality experience. The quality of the geometric data was evaluated by different collaborators in the project. The semantic HBIM was compared to the original 3D point cloud, and the virtual reality model was evaluated based on the, like we had hardware or headsets comparison, and the software was experienced in depth with, for instance, the transfer or the connection between Revit and the Twinmotion software. It was tested twice, once using the DataSmith file extension, the second time with the direct link, which is the second option to transfer the model between the two software. This also was tested. And that's it. Thank you.
Thank you very much, Hend, for your very, very interesting presentation. It was very nice. And at this point, yes, I would like to introduce also the experts that will now give you some feedback. First of all, I would like to introduce Fulvio Rinaudo, who is a full professor in geomatics at Politecnico di Torino at the Department of Architecture and Design, and the vice rector for teaching and scientific activities at Turing Tashkent Polytechnic University in Uzbekistan. His research evolves around innovative photogrammetry approaches, including integrating laser scanning and range cameras for cultural heritage documentation. He also explores GIS applications, multispectral analysis, and AI for cultural heritage preservation. Moreover, he's a pioneer in video photogrammetry for recovering architectural history. Fulvio is also currently the president of CIPA Heritage Documentation. Also, then I would like to introduce Minna Silver. She is an adjunct professor in Near Eastern Archaeology at the University of Oulu in Finland. She was president of ICOMOS Finland from 2018 to 2019. In 2014, she was a professor at Mardin University in Turkey, and since 2020, she has been on the CIPA Executive Board as the Commission Chair for Application of Recording, Documentation, and Information Management for Cultural Heritage. Minna has been a leader of many projects in the field of archaeology, including Sigis, 𝘉𝘰𝘭𝘰𝘨𝘪𝘵, and the Finnish project in Syria. And also, Julia Laninga is a researcher and team lead at Carleton Immersive Media Studio, where she specializes in digitally assisted storytelling. She graduated from Carleton University's Interactive Multimedia and Design program in 2018 and has since focused her work on using game engine technologies as a means for education, public engagement, and storytelling. So at this point, I would like to say that each expert would have 5 minutes to give their feedback or comments to Hend, and then hence you will also be able to respond. And I think I will start with Fulvio. The floor is yours.
Okay, thank you very much, Nefeli, and congratulations to Hend Alasmar for his interesting thesis. Okay, I know your tutor, Gabriele Bitelli, obviously, and in which way they work in this field. So it's just as guaranteed from this point of view. But at least I have some, but I want to know if you have some more idea about some things that comes up. You start with a very strength acquisition from a metric point of view. You use one of the best terrestrial laser scanning, you use digital automatic photogrammetry, you use a structured light scanner that gave level of accuracy very high. After we know that by passing to a BIM model, we have to simplify the things and so to rectify the things, and so we lose many of the metric contents. So one thing that was not clear to me is which are the real aim of your survey. Just to produce a 3D model in a HBIM way in order to show through the augmented reality systems, or there are also other aims? And this is Java. The second thing that I would like to know, because it's very interesting, when you introduce the concept of the level of reliability, you say that is the sum of the level of accuracy and the level of quality. In which way you define the level of quality and which kind of quality you refer to? The semantic quality or which other quality? Because this is not clear to me. And if you find this definition in some references, in some literature, or if it is your proposal, because this is also interesting. After I think that is okay, but it's very interesting. You explain in a good way all the track of the system, but usually in the documentation part, we said that with the documentation we cannot solve all problems. Is documentation ahead as a goal? And we have to provide the data just fit to this goal because we have to consider also the economic aspect. The survey that you did at the beginning is very expensive because you use a lot of instruments, you manage a big amount. And after you produce a simplified 3D model with the aim to show in which way the system hydraulic run, etc., etc., etc. And so the question is always to see, maybe you use too much defined data to obtain the final result. If the result was just the topic of your thesis, maybe a SLAM system could solve quickly in 1 day of survey all the problem you need. Or maybe not. I mean, this is my doubt. I would like to know your opinion, because in this period we are in this part. I mean, when I need to use a terrestrial laser scanning, digital photogrammetry, structured light scanner, and when I can simplify by using a simple SLAM system that today give us a ±5 centimeter of accuracy in both consideration, and you don't have to register, you don't have to things, etc. So this is the discussion open, so it's not a critics to your thesis because it follows a very standard approach, and I appreciate the detail. But just to see the young opinion about this in this period that we are changing a little bit our approach. Thank you, and again.
You're welcome. Should I answer now, or we take other questions and then?
Yes, if you want, you can also answer now, of course.
Sure. Thank you. Actually the first and last question are quite related. The first question is, Again, I have to clarify that my collaboration in the project was not the entire project. There was huge work that was done before and still has been ongoing since I graduated. My collaboration in this work was mainly to see the passaggio, like
I'm Italian, I can understand, but you
okay.
mean the step
Yeah,
between one and the other. Okay.
yeah, like the stepping from the what is now traditional BIM to see and visualize this in virtual reality. And from there, using a very specific software, like we used just Revit and Twinmotion. So it was testing the two software interacting with each other, and also to understand the capabilities that can be developed, like realizing them already after this interaction, what can be done in the future out of this model. It's very true that the level of accuracy of the data that of the instruments that were used for the data acquisition is really high, and it differs obviously from the scanning of the exterior to the interior using the photogrammetry combined with the also the structured light scanner is just another story. So for them to get together in one model, for us, for my thesis, it was not important to use every data or every detail that I have from this output to serve my thesis. In other words, now there is the introduction of level of information need in the BIM field. That was actually a starting point that was brought to my attention by the other tutor. Anna was one of the tutors, and also Simone. And Simone brought to my attention this idea of level of information need, in the sense that not all the information needs to be inserted in our model now for this purpose. We will end up having unneeded data, unneeded information, maybe heavy model that at the end we would use just for the visualization and to document in virtual reality environment. It's meant for this model to be developed in the future, depending on the user. As I said in my presentation, for a museum visitor, he wouldn't need to know about the deterioration of the building, probably, or he wouldn't need to know at least the quantity of this deterioration. For an engineer, it's a different story. So it's a seed model that can be developed in different pathways. So for my thesis, what was needed for it was modeled, and knowing and we are sure that there is richer information that can be inserted in the model, but we didn't need it. We didn't even produce, for instance, construction details from the model. It was just layouts as a point for others to build on in the future if they want to create as built or as is drawing set from this model. The other question is about the level of accuracy. It is actually, it was introduced earlier, this thesis. During the literature review, I learned about the three concepts together: the level of reliability, and accuracy and quality. Now, Build and Smart is still developing the standardization of these three definitions together. The idea was that, yeah, the equation that I put for us, we did not go through this pathway till the end, because developing an index to quantify the level of accuracy is already another topic for research. We, again, in the model, what was modeled, like the information that was inserted in it, was combined by information that would serve in the future to determine the level of accuracy, the level of reliability of this model. It was more of a suggestion, like, look, this wall has rising damp, but by visual inspection, we can say it's 1.5 meter high. In Revit, it could not be modeled as 1.5 meter high, but the wall as an object in the model had this information inserted. In the virtual reality, it was represented as a representation with no quantity associated to it. And so in the future, if they are to execute an intervention on the building for rehabilitation, they would know, okay, this wall is modeled without even going to the location of the building. Just checking the Revit model, they will see the information is saying, okay, wall M01 has a rising damp, and it's written as 1.5 meter to be investigated or to be verified, and so on. But the concept, it was obtained from the literature review, and it's still under research. I hope my answer was...
Yes, thank you. Just to simplify the things, I didn't say to Hend before my question. So the way that he answered to me is another side of the good quality of Hend works. Thank you.
Thank you.
Thank you, Fulvio, for your feedback. So next, Minna, if you would like to provide some feedback and ask some questions to Hend, please go ahead.
Thank you. Thank you for your very nice and clear presentation. And in my view, you are in a very advanced level. Even this is a MA thesis, as I understood. This could be the level could be even PhD in my view. Yes, I'm familiar with industrial archaeology, so I will speak about it a little bit. I have been led an excavation on ironworks and then documented a carpentry with laser scanner and a dam. And then I would like to ask I am a Northern European, and I'm familiar with industrial archaeology, how it is defined here. But it seems that it is defined maybe differently in Italy, because we see the industrial age to start in the 18th century.
Mm-hmm.
And then we talk about the industrial archaeology, and from the Industrial Revolution, which took place in Britain and Belgium and you already referred to this. But for your thesis, it would be good to define this, why you use industrial archaeology in this, was it 15th century hydraulic structure, and why do you see that it's industry compared to what we understand as an industrial age?
Mm-hmm.
So those things I would like to get clearer defined, if you can. And there are sources, especially England is a leader in this field, Britain, and there is a lot of literature on this. Then I liked very much that you were doing the drawings according to the point cloud with those corners that would be 90 degrees, that you followed point cloud accurately and not didn't interpret and put something else there, because it is very important to have this documentation in the original way, that you are following the original structure. And then the machinery that you document them in situ, in the place where they are. Were there any stamps in the machinery? Did you see that there was some production stamps which producers had made them? Did you document that? Did you find any names or anything like that?
Thank you for the questions. For the last question, I'm not really sure. I mean, I cannot answer this question because, to me at least, I don't even know what you mean by the production stamp.
Like if I documented a carpentry, and there were a lot of machines from Stockholm, some industrial producer, and so I documented also who was the producer of these machines, if it's possible, yeah. So, but this is very early age, which you are talking about, so maybe there are no stamps or anything like that.
If your question, if I understood it well, like the producer of the, for instance, the laser scanner or the structured light machinery, one of for the structured light projection scanner, it's by Artec.
No, I don't mean that. The original machinery of the hydraulic structure.
Okay.
The original machinery there, which you documented in situ in the places where they are working, this machinery.
The segment that I dealt with, it did not have such information. Maybe because I didn't even need to have the entire mesh out of this phase of scanning. So maybe in the other segments of the scanned material, maybe it was mentioned.
Maybe. Yeah,
but
maybe
to me, at least, I didn't
visible.
see it.
Yeah, maybe it's visible there.
But this
how about the archival investigation? Did you carry out any archival investigation? You had one picture which you seemed to be this kind of section of the
profile
of the structure, but is there available other archival information?
The information that I could obtain were from mainly two sources. One from the archives of the 𝘋𝘐𝘊𝘈𝘠 library in Bologna. The other, and actually very important material that was found was in the Museum of Industrial Heritage of Bologna, that is very close to the project site, to the building. Actually, I can check because the picture of the profile, I can tell you even where I got it from, because it was a book.
Yes, I saw it was a book.
Yeah,
yes.
That was from the library of 𝘋𝘐𝘊𝘈𝘠. The information were scarce, and some of them were even photos in catalogs from like interested individuals in the paesaggio, the landscape of Bologna. But these photos could lead later to information. Like, okay, this is a picture of from Bologna in 1940. So in this photo, tracing this photo, because it could be found in other similar photos from more or less the same period of time, was showing that the navigation log used to look like this. So this is an interesting information that could be documented, again with the referencing, the proper referencing, to say that it was obtained not from the archives, not from the museum, but it was a personal collection and photos in brochures or books that are not as important as the main book that I used for the profile section, for instance.
Okay, good, good.
Yeah, for the industrial archaeology question, actually, for more than one reason, it could be interpreted as industrial archaeology. To begin with, this structure was providing water and electric power to its surrounding, and this surrounding was an industrial zone where there were there was a silk factory, not today's factory, obviously, and also there is the 𝘊𝘪𝘷𝘪𝘭𝘢. It's like a brick factory or brick kiln that is actually today is the museum. That industrial archaeology or industrial heritage museum, it used to be that kiln for brick, and there was silk, also rice production in this zone, and they used the electric power and the water that was regulated by this lock to serve their purpose.
Okay.
And
so the structure is earlier than the use later on, and it has been used as an other purposes, for other purposes earlier on. Okay, I understood.
Also to transfer the material to these industries. It was not just electric power and water supply, but also the navigation through these canals. It granted the arrival and transportation of either of material, raw material to them, or for the goods that they produced. It lost its functionality throughout the evolution of the industrial revolution by then, like in the second and third wave. And when the urban planning changed in Bologna, and even the canals were like all these locks no longer serve its purpose, so it lost its functionality, but still it stands out as an industrial archaeology site.
Great.
Historic industrial archaeology.
Yes. Now it became clearer to me. Thank you very much. It was very interesting and really nice that you are documenting such a site. So congratulations. Thank you.
Thank you, Minna. So we'll move on to our final expert feedback from Julia. And so just a note, we're running over time, and so we won't have any time for questions from the audience. We'll just go through the final questions from Julia and some feedback, and then Hend, you can take a moment to respond to Julia's questions. Go ahead, Julia.
Thanks so much, and thank you for the presentation. That was really interesting, and your final product looked really great. I was wondering if you could maybe give a little bit more detail on what the kind of end user experience was like in the headset. So how the user would interact with the scene and maybe how they would navigate the model within the headset.
Sure, yeah. Actually, I would like to maybe start sharing, if possible, really quickly one example. While I'm talking, I'm responding to your question. For the end user experience, obviously you will be or the user will be in a one-to-one scale environment. So you're seeing the real height and all the real dimensions around you. And with wearing the headset and using the two controllers in your hand, or one, depending on the set that you're using, you would, depends on how the model was produced. Some elements would be, once you trigger, it will give you information. Some elements were left for just appreciation for its detailed architecture or for its decoration. For instance, there was a stone part on the gate, on the main gate of the building, that commemorates the order that was given by the Pope to restructure or to reconstruct today's 𝘉𝘯𝘪𝘓. And it shows also the date, and it was written in Latin, at least in Latin numbers and Old Italian, if I'm not mistaken, because I don't have it right in front of me now. So that was left as it is without any notes. But for the user, if he wants to know what is this, they would hit it with the trigger it with the handset, and they would see what the text that is in reality found. Like, we did not have to model the text; it was added as a note. I can show you, for instance, this. I don't know if you can see my screen. Yep. That was the Vive Pro 2.
In the reality.
That was just a trial for us. You hit the door, like you point at the door, and it opens. Then you enter the machinery room. Okay. That was still under development, the model.
But the gates.
That was actually Anna helping with like directing the. I'm trying to stop sharing. Okay. Yeah. Okay. Whatever. I'm unable to stop sharing, but there is also another video. Yeah, this is the other headset actually. That was the lower resolution headset, the Oculus. You see here the modeled deterioration on the walls, for instance, that I mentioned before, that it's not qualitative. Sorry, it's not quantitative. It's just to point out that here there is a deterioration. That was us trying to navigate with the handset. Arrive into the log gate, and then you point at it and it rises up. And all this while you are wearing the headset, you are in a scale 1-to-1, and you feel like you are in the water and you can hear the sounds. And that was also an interesting aspect. While you're modeling a BIM that will be used in virtual reality, you should consider it's not like the level of accuracy is different, because okay, when this, I cannot put anything under this gate. It has to be really well modeled, because in virtual reality later, if somebody points at this gate to level it up, they cannot find anything like a void or something. No, it has to be modeled as terrain. In Twinmotion, for instance, all these animations were also had to be redesigned more than once to get to this sequence. Because thinking, like, I put myself in the shoes of the user, I would want to maybe to see this door open. So I make a decision that this has to be leveraged up, and I have to see water, and I need to listen to water, and so on. Actually, the step of creating the virtual reality model was really was interesting, because we also learned about, like, we put ourselves in the shoes of the user, and you start to think, okay, am I now an engineer, or I'm a visitor for the museum, or I'm just a random person trying headsets, and so on. Yeah, so that's it.
That actually answered one of my other questions, which is how you kind of considered your target audiences and incorporated interactions for both in the application. I'm curious if moving forward, you would see developing two separate applications, one for engineering or one for museum visits, or if you saw overlap in the functionality that both audiences would look for.
To me, as an engineer, especially working in rehabilitation, structural rehabilitation field, I would appreciate more if the virtual reality software would grant me a higher level of, okay, I will rephrase this. If it will grant me more quantitative representation of deterioration or of damage, whatever, like any kind of damage that we have, either material deterioration, there are plenty of them, cracks, settlements in the or landfill or something. So I would need this to be seen, and also to have easier, like that was quite easy. It was manageable to take dimensions in one of these two visualization experience. Also, we try to take dimensions to take measurements from within the model. That was possible. Also, cutting sections. But it would be better, to me at least, as a user who's an engineer or architect, that I would want I want it to be easier to learn about the information coming from Revit. Because in this case, while visualization, pointing on a brick wall, the wall was modeled in Revit like brick masonry, or some, let's say, brick masonry with two finishing layers from inside, like interior and exterior. From what I experienced, maybe it was developed later through Twinmotion, again, to specify the software, because the other softwares could be used to develop the visualization of the model. It wasn't easy and intuitive to trigger or to point on the wall and it tells me the layers. No, it has to be added as a note from the model, apart from the fact that it's already inserted in the Revit model. But going into the Twinmotion, it has to be added as a separate note that you click and it will pop up on the screen. Could be that it was developed later. Could be that I did it in a different way than it should be done. But that was the experience within the time frame that we had to this part of the thesis. Maybe in the museum, it's less likely that someone would want to know the stratigraphy. And from the interface of the model, I think it can be added, like the kind of user. Are you a heritage enthusiast? Are you a restorer? Are you an engineer or architect? So depending on the user, the model will have limitations or delimitations to show to that user that you choose.
Thanks so much. I have one more maybe piece of feedback or just comment. You had mentioned the optimization and how you would run into a bit more lag with the Quest headset versus the Vive. I'm not sure if there was any optimization done to the meshes themselves or the amount of geometry in the scene, but maybe just a piece of feedback if you're moving forward and hoping to get it onto a wireless headset. One thing that we do a lot of work in when we're bringing BIM into VR is reducing the number of meshes that we have in the scene and reducing the polygon counts as much as we can to make sure that everything's running as smoothly as possible. So that could be a way that you can get things running a little bit smoother on the wireless headsets is to, I think Datasmith has some options, look into how Datasmith can help make those reductions, but also removing meshes that maybe won't be visible and re-optimizing some of the topology of the meshes could be a way to help bring it into those other headsets.
Actually, I wish to add to what you're saying that it's correct that we, while exporting through Datasmith, you have different options to reduce the quality, maybe to get out the material from Revit and just the material that you add in the in Twinmotion. However, for the sake of this comparison, we had to maintain the same level of richness, or the same exact model was used for both headsets to be able to measure the how to say, the strength or the full capacity of them. And so that was the point of the comparison. But yeah, of course, I completely agree with you.
Great, thank you so much.
You're welcome.
Thank you, Julia. Okay, so that wraps up our event. Fulvio, do you have one final comment?
Yes, just some precision, because the question of Minna were very correct, but actually after Hend explained the things, just to know that this houses was started in 15th century. After on 16th century was completed, but just to provide normal water to the inhabitants of Bologna, etc. But at the end of the 18th century, it took the name of battiferro, that means hammering iron. And there was some mechanic system that moved the hammer through the water. So this is the meaning of the industrialization. And after, in the 19th and 20th century, it provided electric power, etc., to all the industry. So this is just to justify the meaning. But actually, yes, they use an already existing building for other things that, if you go into the urban history domain, you find that the people that are interested about hygienic condition, etc., they point out this. The name just raised up at the end of the 18th century when they transformed this building in a place where they hammer the iron and other metals. That's all.
Thank you, Fulvio. Anna, I don't know if you have any more comments, but we're getting pretty past our time, so comment.
Just to answer to the question of Professor Minna about the company that produces the equipment, we actually know which is the company, the 𝘋𝘊𝘪𝘑 company, which is an historical company from Bologna, which was very important in the industry of this territory during already the 20th century, and now it's still existing and it's incorporated in a bigger company, which I don't remember the name of, but we actually know the name of the manufacturer. There is a small say signal on the machinery to identify the name, and that is also why it was considered as an industrial archaeology, because that company was actually in the 20th and 21st century was making the industrial power, the industrial strength of the Bologna territory. So it was a very important company, actually. 𝘋𝘊𝘪𝘑, call it 𝘋𝘊𝘪𝘑.
Thank you, Anna. Well, thank you all, Fulvio, Minna, and Julia, for your feedback. I think this has been a really great discussion and some good feedback for Hend. So hopefully this has helped your research process. And thank you, Hend, so much for sharing your research today. It's always really great to see the work that different people in the CIPA network are doing. So we will be sharing the recording of this presentation online after the event today. But if you have any questions for us or for Hend, please reach out. And so thank you everyone for joining today. Take care.
Thank you so much. Have a
Thank
lovely
you,
evening.
thank you very much.
Thank you.
Congratulations, and bye-bye to all.
Thank you.
Bye, Minna. See you later.